Throughout scientific history, one name stands out when it comes to the savior, which was synthetic fertilizer. Yet that very same name is also stained with the indignity and tragedy of death. So how can one man create so much life while also providing such a strong hand of death? This is the story of Frizt Haber. His introduction to the scientific world seemed perfect in terms of saving the world from starvation. But when he got too much glory from it all, he turned to a side of terror for the Allied powers. Frizt Haber's scientific findings yielded many pivotal contributions that completely shifted the course of chemical history. His creation of the ammonia compound and nitrates revolutionized agriculture, which were responsible for vast increases in many developed countries, populations, and many more able bodies for World War I, as well as much more of a devastating type of warfare due to his creation of chlorine gas. His contributions to science were critical milestones to transitioning into the modern world. The year is 1889. The world faced a daunting problem that would have threatened the existence of humanity. For thousands of years, we have been relying on farming in order to feed populations. The practice was almost perfected, yet there was still one problem that rightfully scared both farmers and chemists. At the turn of the century, the problem could no longer be ignored. Both governments and the scientific community recognized that a failure to solve problems would lead to starvation throughout the world. It became clear that someone needed to step in and save humanity. The problem comes when farmers repeatedly farm the same land over and over. All the nitrogen in the soil, essential in agriculture, would eventually be used up. After this happened, there was no sustainable way to replenish it. At the same time, the Industrial Revolution facilitated a substantial growth in population in developed countries. A population that would not be able to be sustained without proper nutrition in the soil. How could there be enough food to feed all the people? This was the question British chemist and physicist William Crookes discussed in his address of the President before the British Association for the Advancement of Science.
Many of my statements you may think are of an alarmist order. Certainly, they are depressing, but they are founded on stubborn facts. They show that England and all civilized nations stand in deadly peril of not having enough to eat.
But at the same time, he proposed a solution.
It is the chemist who must come to the rescue of the threatened communities. It is through the laboratory that starvation may ultimately be turned into plenty.
This is what Frizt Haber was dealing with when he joined a long line of failed chemists. But he was determined to find a solution through years of trial and error, as well as some luck. Haber was able to come up with the process that turned the most abundant element in the atmosphere into a compound that plants could use. Because of the incredibly strong triple bond that nitrogen holds together, tremendous amounts of pressure and heat are needed to separate it into a compound for plants. The process was revolutionary. The world sighed with relief. Now with his process, farmers had the nitrogen to grow enough food to feed the people. His process was arguably one of the most significant scientific breakthroughs in all of history. While they may not have realized it at the time, we can now see through analyzing the short and long-term impacts of his process that Haber changed the course of history. At first, the ammonia synthesis significantly increased agricultural productivity. Farmers were able to grow 4 times the amount of food in the same plot of land with ammonia than without. But it's in the longer-term impacts that you can see how influential he was. Today, 40% of nitrogen used by plants is from ammonia. Translate that to humans. Because we get all of our nitrogen from eating plants or animals that eat plants, 1/3 of our diet depends on ammonia, so that we can produce the necessary proteins for our bodies to function. 50% of the nitrogen atoms in our body come from the Haber process. While it is not widely known, ammonia is crucial to our lives. 1/3 of the total food we eat was made possible by the invention of ammonia, confirming the process as the cornerstone of our diets. Such a significant basis of our diet on a single invention proves that it is a turning point. Looking back, we can also look at the impact the invention had on our world. While there may have been many factors contributing to such exponential growth in population, the involvement of ammonia cannot be overlooked. Ammonia allowed the Earth to support 4 billion more people than without. It also predicted that the next 2 billion people born will be dependent on the Haber process. According to Derek Muller, a scientific communicator at the University of Sydney,
There is a good chance you owe your own life to Haber's invention.
Because of ammonia's enablement to grow populations, we could progress into a modern world. There have been numerous examples of how having a high population drove progress in the modern world. For example, more people means a large workforce and more consumers, which significantly improves an economy. One example of this is China's rise as an economic powerhouse, exemplified by its abundant workforce and global demand for its products. In America specifically, urban population growth developed a larger infrastructure and created cities of innovation, a large part of America's modernization. In conclusion, it is clear that Haber's invention of ammonia was pivotal in transitioning into a modern world. It made the population growth of the 19th and 20th centuries possible, which drove the innovation and development needed to transition into a modern world.
Taking a turn, we will now focus on the deadly effects ammonia had on the world. This is where the tragedy starts, where the blemish of Fritz Haber's name comes. The year is 1914, and the Great War has commenced. The Central Powers and the Allies were sprinting to find their next lethal weapon. The Central Powers hired Fritz Haber, the leader of the Kaiser Wilhelm Institute, along with other scientists, in the hope that they would create a new lethal gas weapon to win the war. Haber, being a loyal German, took on the challenge and went to work on his new weapons. His first lethal weapon was chlorine gas. Chlorine is a diatomic gas, 2.5 times denser than air. It is best described by British officer Martin Greener during the attack at the Imperial War Museum on the 31st of January, 1941.
The next thing we heard was the sizzling, I mean, you could hear this damn stuff coming on, and then saw this awful cloud coming over. A great yellow, greenish yellow cloud. Then word came. Whatever you do, don't go down. You see if you got to the bottom of the trench. You got the full blast of it, because it was heavy stuff. It went down.
Chlorine chemically reacts with the water in the lungs to produce hydrochloric acid. This acid swiftly rips tissue from the lungs and leads to a quick death or permanent tissue damage. Even if chlorine was only the start to chemical warfare, and soon many other gases would be created by Fritz Haber. The most lethal being phosgene, or carbonyl dichloride. Haber's gases caused approximately 1.3 million casualties and 90,000 deaths. The lasting effects of the gas came in paranoia. Soldiers would see friends of theirs slowly die in front of them by phosgene, or always be on the lookout for large clouds of chlorine gas. This lack of sleep from the paranoia caused great decreases in morale and mental stability. After the Great War, Europe stressed over the uses of gases in future warfare and how they could develop. Chemical warfare with gases became prohibited by the Geneva Protocol of 1925. Only a small amount of poison gases have been used since.
While Haber's gases themselves brought so much death, we believe that they were just the start, the beginning of a transition into a modern type of warfare. After chlorine gas had been invented, a whole new world of warfare was opened up, and because of his creations, modern warfare drastically changed. As seen in the Geneva Convention, it required a type of diplomacy that showed a new restraint and concern for international military conflict. The paranoia caused by the gases was a new factor that changed how soldiers viewed the war. The indirect psychological effects of these weapons in itself were a new way to destroy the enemy. Yet the most devastating impact of Haber's inventions were Zyklon A and B. Originally just hydrocyanide-based insecticides, they were used after Haber's death to perpetrate the Holocaust. Haber's inventions brought death to millions of innocent civilians. These gases revolutionized warfare into a more destructive, but modern type, one that we still see the effects of today. In the beginning, we asked how one man could bring so much life, yet also have such a devastating force of death. We hope it is now clear how that was possible. While Haber did much good for this world, it is important to not forget how much death he brought as well. Through it all, though, it is undeniable that his inventions of ammonia and chemical weapons were pivotal into transitioning into a modern world.